Not that far away from the planet, generally speaking, researchers have found a new planet known as Proxima B. Stargazers, as of late, uncovered the most keen picture ever captured of Proxima B using the notable James Webb. This planet is in the orbit of the star closest to our Sun, and this wonderful picture offers a remarkable glimpse into a world beyond our immediate vicinity. A planet-wide organization is asking questions and sparking excitement among researchers worldwide. Yet how did this telescope accomplish such an achievement? Could this picture open a window to a location that might have conditions appropriate for life? At last, what does this new discovery mean for how we interpret exoplanets and the immense universe beyond? Join us as we investigate the newly discovered picture of Proxima B, captured by the James Webb Telescope. A strange planet. Proxima Centauri b sits within the vastness of space around its star, Proxima Centauri, a simple 4.2 light-years away from Earth. This distant planet has captured our imagination, raising inquiries about its likeness to our own. Might it be compared to Earth, which has abundant seas and, with the addition of life, further deepens the interest? Proxima Centauri isn't alone in its journey. It shares an orbit with another sizable planet, Proxima Centauri c. Proxima Centauri gives off about the same energy from its star as Earth gets from the Sun, making researchers inquisitive about whether this distant planet could have water or support life. As we explore the endlessness of space, we encounter various exoplanets, worlds circling stars beyond our Sun. With a perplexing 206 trillion stars scattered across the universe, the opportunities for these exoplanets seem unlimited. A portion of these planets wander freely through space, similar to enormous migrants. Proxima Centauri b stands out as a unique riddle in this broad array. The length of its year is surprisingly short, lasting just 11.7 Earth days, and it revolves around its star multiple times closer than Earth does to the Sun. Thus, one side of the planet is constantly bathed in sunlight while the other remains in endless darkness, adding to the planet's strange and possibly wondrous nature. How did James Webb capture this image? Proxima B was initially found using the radial velocity method, an earth-shattering procedure in finding exoplanets. This method depends on noticing the subtle movements of a star caused by the gravitational pull of a circling planet. As the planet orbits its star, it causes a small but discernible movement, making the star change its position slightly. Experts in space can spot this development by carefully studying changes in the star's spectral lines, a phenomenon called the Doppler shift. Proxima B, with these minor adjustments in the star's spectrum, reveals its presence, displaying the radial velocity method's effectiveness in uncovering worlds outside our nearby planetary group. The acknowledgement of Proxima B was a critical accomplishment, since it confirmed the presence of an exoplanet within the habitable zone of the closest known star to our Sun. This discovery ignited tremendous interest among specialists, space researchers, and enthusiasts worldwide. They are anxious to explore the potential mysteries Proxima B could hold and what this finding means for our understanding of the universe and the possibility of life elsewhere. Proxima Centauri b is an infinite wonder worth marveling at. Picture 3 celestial companions, Regulus, Canopus, and Proxima Centauri, traversing the vastness of space, forming the closest star system similar to ours. As we investigate the night sky, Regulus and Canopus merge into a brilliant guide, shining together in the Centaurus constellation. These stars are ranked third in brightness, stunning us with their splendor at a peak magnitude of 0.27. However, it's the modest Proxima Centauri that holds an intriguing secret. Also referred to as Alpha Centauri c, this red dwarf, belonging to the T-type family, lives just 0.21 light-years from its brighter companions. To put it into perspective, that's multiple times farther than the distance between Earth and the Sun. Its name, Proxima Centauri, meaning closest star in Latin, highlights its status as our closest celestial neighbor. Back in 1915, Scottish cosmologist Robert Thorburn Innes revealed this divine diamond to the world. Regardless of its proximity, Proxima Centauri continues to be difficult for the untrained eye to detect, displaying an apparent magnitude of 11.13, far beyond the natural eye's visibility threshold of 6.5. Nonetheless, the clearest image revealed is an achievement in its own right. Red dwarf stars like Proxima Centauri are enormous forces to be reckoned with, effectively producing energy through strong internal convection processes. This star will happily maintain its position as a primary sequence star for another 4 trillion years, exhibiting a lasting brilliance that spans the ages. However, the concept of habitability around Proxima Centauri comes with its fair share of challenges. Being a flare star, sudden and unexpected events occur in Proxima Centauri. Unusual eruptions of energy. Its lower mass suggests that the habitable zone, where life-friendly conditions could exist, is much closer in comparison to our Sun's habitable zone. Enter Proxima B, a planet situated within this zone, at a distance similar to Earth's orbit around the Sun. But appearances can be deceiving. Proxima B combats powerful ultraviolet radiation, many times more intense than the sunlight reaching Earth. This extreme radiation poses a danger even to atoms of hydrogen, threatening the stability of essential elements like nitrogen and oxygen. Likewise, merely occupying the Goldilocks zone doesn't guarantee a sustaining environment for life to prosper. Proxima B may lack the vital environment necessary to support life, manage climate, and cultivate a surface suitable for water. Without shielding from an aggressive atmosphere, any potential life forms on Proxima B would be exposed to the brutality of space, significantly reducing the likelihood of life as we understand it. The mission to uncover the secrets of Proxima B, despite its challenges, continues to be a driving force in the realm of space exploration. Among the tools fueling this invaluable research, the James Webb Space Telescope stands out. Launched at the end of 2021, following numerous delays, this cutting-edge telescope holds the promise of shedding light on one of the most tantalizing mysteries of our time. Questions in cosmology. Does life exist on Proxima B? The path to uncovering Proxima B's truth is far from straightforward. The James Webb Space Telescope underwent significant adjustments to guarantee its image's accuracy. According to a renowned Harvard Proxima theoretic physicist, B requires a nuanced approach. Situated inside the habitable zone of its star, the Earth has the capacity to absorb and emit life-sustaining infrared radiation that makes it possible for life. This advanced James Webb Space Telescope instrument can capture faint light from the planet's surface, aiding researchers as they look for evidence of water or an atmosphere. What scientists are saying: the crucial question of whether Proxima B, where water plays an important role in interpreting this nearby exoplanet, could harbor life. The presence of water substantially affects the possibility of life as we know it. Water is an essential component. If found on Proxima B, life on Earth would greatly increase the likelihood of the planet being habitable, or at least capable of supporting some form of life. Proxima B, located within its star's habitable zone, receives the same amount of solar energy as Earth receives from the Sun. However, due to its proximity to its red dwarf star, the planet faces intense stellar radiation and magnetic disruption, potentially threatening the stability of any potential atmosphere. Furthermore, the presence of liquid water is still in question. Currently, scientific models and the use of simulations examine a variety of scenarios for Proxima's environment and possible water reserves. A few hypotheses suggest the existence of planet-wide vast oceans, whereas others contend that any water may be trapped as ice or buried beneath the planet's surface. Directly identifying water on Proxima B presents an imposing challenge, requiring advanced telescope technology and specific atmospheric conditions. As our observational tools keep expanding, the mystery surrounding Proxima B's atmosphere and potential water reserves is expected to unfold, bringing us closer to truly understanding the nature of this captivating exoplanet. Yet the presence of an atmosphere alone doesn't guarantee Proxima B's habitability. Ed Turner, an astrophysicist at Princeton University, cautions against assuming habitability based solely on an atmosphere. He warns that the planet may resemble Venus, with a thick, choking atmosphere and extreme heat, rendering it unsuitable for life as we currently understand it. Proxima B, beyond being just another distant exoplanet, emerges as a fascinating neighbor in our vast backyard, tantalizing us with the possibility of life. Its proximity creates conditions that make it a tempting target for future space missions, sparking the interest of cosmologists and space enthusiasts alike. Although direct travel to Proxima B remains beyond our current technological strengths, it holds a place on the horizon for potential interstellar missions. The challenges inherent in reaching Proxima B are indeed immense. A journey using existing spacecraft technology, exemplified by Voyager 2, would necessitate an incredible 23,000 years. Could Proxima B support life? The drive for new ideas and human imagination pushes space exploration forward, presenting potential solutions like solar sails. These ultra-thin sails could revolutionize space travel, pushing spacecraft at remarkable speeds and possibly reaching the Proxima Centauri system, where Proxima B resides, in 20 years. This technological leap brings the desire to travel to an Earth-like exoplanet within our lifetime tantalizingly close to reality. The discovery of Proxima B has reignited human fascination with the universe, instilling a renewed sense of hope and wonder. It stands as a testament to our never-ending desire to enter the unknown, discover new worlds, and contemplate the existence of life beyond our planet. While the James Webb Space Telescope represents a marvel in modern astronomy, it is not without its limits. Despite its extraordinary ability to observe celestial objects and shed light on the potential for life on exoplanets like Proxima B, it battles challenges in interpreting the presence of atmospheres and identifying conditions conducive to life. Proxima B, with its atmospheric similarities to Venus, serves as a stark illustration that an atmosphere alone does not guarantee habitability. Nonetheless, the telescope's exceptional ability to detect even the faintest signs of life, such as bright orbital mirrors that a potential development on Proxima B could use, highlights its vast potential. Our universe, with its vastness and mystery, holds within it a surprising array of planets eager to reveal their secrets. These celestial bodies, known as exoplanets, orbit stars far beyond the reaches of our solar system, displaying a remarkable variety in their sizes and shapes. Some mirror the giant gas monsters like Jupiter and Saturn, while others resemble our very own Earth. Gas giants stand as perhaps one of the most enchanting classes of exoplanets, captivating cosmologists worldwide. These planets, similar in structure to Jupiter and Saturn, often outperform them in size. Superjupiters are known for their sheer scale. They are so massive that they render Jupiter, our solar system's largest planet, relatively small. Alongside these immense entities reside the hot Jupiters, gas giants orbiting perilously close to the stars they host, exposed to temperatures capable of melting metals. Studying the characteristics of such planets reveals a world on fire, characterized by violent storms and scorching heat. However, the exoplanet category is not limited to these giants. Neptunian exoplanets, similar in size to Neptune and Uranus, are among them. Hot Neptunes and small Neptunes, smaller cousins settled closer to their host stars than their larger relatives, have atmospheres that remain enigmatic and challenge our understanding. Final thoughts and future discoveries. The quest to understand distant exoplanets like Proxima B has led researchers to develop cutting-edge technologies that increase our understanding of the universe. As the study of extrasolar planets continues to advance, methods such as the transit method, observing the slight dimming of a star's light as a planet moves past it, have revolutionized our ability to detect and investigate planets beyond our solar system. This technique has revealed thousands of exoplanets, many of which exist in the habitable zone of their stars, where the conditions might be suitable for liquid water to exist. Such discoveries fuel the imagination and bring us closer to answering one of the most profound scientific inquiries. Are we the only ones in the universe? In addition to the discovery of planets like Proxima B, astronomers are constantly refining their search for biosignatures, indicators that could reveal the presence of life on distant worlds. By studying the environments of exoplanets, scientists can identify gases such as carbon dioxide, methane, and oxygen. Gases often linked to biological processes. The James Webb Space Telescope's potent infrared capabilities are expected to be instrumental in this area of research, enabling the detection of these gases even on planets that are light years away. If scientists can confirm the presence of biosignatures in the atmosphere of an exoplanet, it would provide strong evidence that life could exist in other parts of the universe. We are getting ever closer to answering the question: Are we truly alone in the cosmos? But even as we look outward toward the stars, the search for life in our own solar system is ongoing. Planets like Mars, moons such as Europa and Enceladus, and even distant bodies like Titan have been studied for the presence of organic compounds, liquid water, and potential habitability. While these bodies are much closer to home, they still present challenges when it comes to exploring the possibility of life. For example, Europa, one of Jupiter's moons, is believed to have a vast ocean beneath its icy surface. Scientists are hopeful that future expeditions to Europa might shed light on whether microbial life could exist in the subsurface ocean, a finding that would have profound implications for our understanding of life in the universe. The role of robotic exploration in these efforts cannot be overstated. Rovers, landers, and orbiters have been essential in gathering data from Mars and other planets. The Perseverance rover, for instance, is currently exploring Mars, searching for signs of ancient life and collecting samples of soil that might one day be returned to Earth for analysis. These missions are pushing the boundaries of space exploration, allowing us to gather information that may in the future lead to the discovery of life beyond Earth. The future of space exploration is likely to concentrate on the search for more Earth-like exoplanets, with missions focused on studying the atmospheres and surfaces of these faraway worlds. With the development of new technologies and the continual advancement of space telescopes, scientists will be able to make even more in-depth evaluations of exoplanets.